Okay, so we are now in chapter 11, section 3, and before we were graphing radicals. The other day we were um, solving for radical expressions. Now we are solving for radical equations, and there are certain steps that you must take in order to solve a radical equation. First step is we must isolate the square root on one side of the equal sign. Next is we're going to square both sides, so we get rid of that square root. Third step is we solve for x. And the fourth step is probably the most important step because this will determine if we have a correct answer or not. And we can determine that if that x works out, it'll check out. So let's get started. What do you mean by squaring both of the equations? We can take into account that we can make the assumption that if a equals b, then a squared would equal b squared. So the example they kind of give us is what if the square root of x equals 3, and by using the steps we isolated our square root, we're going to now square both sides of our equation to get rid of our square root to solve for x, and our x would equal 9. So if we took the square root of 9, that would equal 3, and it would check out. So let's do some examples. So, whoops, let me try again. Okay, sorry about that. All right, so these examples A and B, and I think there's a C down there too. We want to solve the radical equation by squaring both sides. So what was the first thing we need to do? First step is we must isolate the square root on one side of the equal sign. So to do that is we're just going to use algebra. So we're going to, first off, I'm going to add 6 to both sides. So that cancels. So then I have 3 square root of x equals 6. I still need to isolate, so I need to divide both sides by 3, which then gives me the square root of x equals 2. So we did step 1. Step 2 is now we must square both sides of our equation. So I'm just going to square this and square that. And the square root of x squared is just x, and 2 squared is 4. So for my equation, x will equal 4. So if I were to now do step 4, I'm going to substitute in 4 for x. Square root of 2, or square root of 4, it equals 2. 2 times 2 is 6. 6 minus 6 equals 0. So that checks out. So this is a true statement. Let's go to B. We have 4 times the square root of x minus 7 plus 12 equals 28. So let's do step 1. Let's isolate the square root. So I'm going to subtract 12 to both sides. That cancels out, and now that gives me 4 square root of x minus 7 equals 16. I'm going to divide both sides by 4, which now gives me the square root of x minus 7 equals 4. So step 1 is done. I isolated the square root. Now they want us to square both sides. So I'm going to take this, make this square, make this square. Now I have x minus 7 equals 16. So now I'm going to do step 3. Now I'm going to solve for x. So I'm just going to add 7 to both sides. And it gives me x equals 23. Well, let's see if that checks out. So I'm going to substitute in 23 minus 7 plus 12 equals 28. 23 minus 7 equals 16. So I got 4, 16 plus 12. And the square root of 16 is 4. 4 plus 4. 4 times 4 is 16. Plus 12 equals 28. Does that check out? 28 equals 28. So that checks out. Let's look at C. Jeez, I'm having trouble here. So the problem for C is the square root of x minus 12 minus x plus 3. So how I plan on doing this problem is I'm going to add square root of x plus 3 to both sides, which then that leaves me with square root of 4x minus 12 equals the square root of x plus 3. Now I want to square both sides. So that leaves me with 4x minus 12 equals x plus 3. Now I'm going to subtract x both sides. So leaves me with 3x minus 12 equals 3. I'm going to add 12 to both sides, which gives me 3x equals 15. Divide by 3. And that leaves me with x equals 5. So let's see if that checks. So I'm going to have 4 times 5 minus 12 minus square root of 5 plus 3 equals 0. So 5 times 4 is 20. 20 minus 12 is the square root of 8. Minus 5 plus 3 is the square root of 8. And the square root of 8 minus the square root of 8, it would be 0. And so that checks. Last thing we're going to do is talk about extraneous solutions. Extraneous solutions are extra answers that you get when you are finding square root equations that don't work. So it's very important to make sure you check the solutions to make sure that they work. What I mean is if you find yourself having a negative number in the square root, then it cannot be a solution. The only way it works out is if the result inside of the square root is a positive number. So let's take a look. I'm going to extend this a little bit, maybe just a little bit more. Went too far. I am having difficulty with this. Okay. So A and B, we want to solve the radical and check for extraneous solutions. So let's take a look at A. So we have the square root of 20 minus x equals x. So so step 1 in solving equations is to isolate the square root. That's already the case in this point. So let's go right to step 2 and square the both sides. So the square root of 20 minus x squared is just 20 minus x equals x squared. Now, what I'm going to do is I'm going to move my 20 minus x onto the other side. So it would be, I'm going to add x to both sides, and I'm also going to subtract 20 to both sides. So then that leaves me with 0 here, and x squared plus x minus 20. And this kind of looks like a quadratic, which is what we learned in chapters 9 and 10. So this goes back to using the zero product property. So I can factor these out, parentheses, parentheses. If it doesn't factor out, you could always use the quadratic formula. But this one does. So I got x and x. The negative 20 tells me that they're going to be a different sign. And the x is a positive here, so that means that the larger number is going to be positive. So that factors out. So now using the zero product property, I have x equals negative 5 and x equals 4. So I got two answers now. So either both of them could be a solution, one of them could be a solution, or none of them could be a solution. So let's take a look and see if we have any. So let's double check our work. So I have, let's use negative 5 first. So I had the square root of 20 minus a negative 5 equals negative 5. So I have plus plus, and so that gives me the square root of 25 equals negative 5. The square root of 25 is just 5, and 5 equals negative 5. Well, in this case, this comes out as a no solution, because 5 cannot equal negative 5. So negative x equals negative 5 is a extraneous solution. So let's try 4. So I have the square root of 20 minus 4 equals 4. Gives me the square root of 16 equals 4. 4 equals 4. So that checks out. So my answer here would be x equals 4. Looking at B, I have the square root of 2 minus x equals x plus 4. So step 1's already done on this one. The square root is already isolated, so step 2 is just to square it. So the left-hand side will leave me with 2 minus x, and the right-hand side leaves me with, this is the same way as writing it as x plus 4 times the quantity x plus 4. So we have to FOIL it. So this gives me x squared plus 8x plus 16. And I'm going to get my 2 and 2 minus x to the right-hand side of the equal sign, so it's set equal to 0. So I'm going to have 0 equals x squared plus 9x plus 14. Because I subtracted 2, I added x. So see if it factors out, which it does factor out, but if it didn't, we could always use the quadratic formula to help us out. And since 14 is positive and 9 is positive, they're both going to be a plus sign here. And two numbers that sum is 9, and product is 14 is 7 and 2. And using the zero product property, my x will equal either negative 7 or my x would equal negative 2. So now we've got two answers. Now we must substitute them back into the original equation to see if there are solutions or not. So let's go with x equals negative 7. So I'm going to go square root of 2 minus a negative 7 equals a negative 7 plus 4. So this just gives me plus plus, which means that 2 plus 7 is 9, so that's square root of 9 equals a negative 3. Square root of 9 is 3 equals a negative 3. So that does not equal, so that does not check out. So that is a negative 7 is a extraneous solution. Let's try see if negative 2 works. So let's go negative. So square root of 2 minus a negative 2 equals negative 2 plus 4. So we got plus plus, so that gives me the square root of 4 equals 2. And square root of 4 is 2, and so that checks out. So my solution here will be x equals negative 2. So just automatically assuming that if you get a negative number in for x, means that it cannot be a solution. You can't assume that. You must use that fourth step and double check your answers to make sure that they are true solutions or not. And this is how you solve radical equations. Make sure you use the steps, and it is very important for you to check your solutions from the original equation to make sure that they satisfy that particular equation. And I hope this helps. Until next time.